Now we are going to discuss about center of mass. This is a point of a systems of particle about which the whole masses, individual masses M1, M2 or M1, M2 up to nth particle are supposed to concentrate, about which the motion is, about is the motion body is applied a force to make it for the translation or a rotational motion. So we can define center of mass, body is the point where the entire mass of the body is supposed to concentrate. Suppose this is the axis of rotation, this is M1, this is M2, this is M3 and say mnth particle. It is at R1, it is at R2, it is at R3, it is at R4. So center of mass is a point about which all the masses, n number of masses supposed to concentrate. So about which a body can rotate or can accelerate or can have velocity. Let's have an example. First we will derive the derivations for Fm. Suppose this is the axis of rotation, there is a rigid body and this is about axis and there is a M1, there is a particle M2, there is a particle M1, there is a particle M3. For simplicity we have taken three particles which are at a distance of x1, x2, xn, x3 and xn. So center of mass about x-axis. It means the body is rotating about from x-axis how much distance. Center of mass is defined as mass of first particle and its distance from the axis of rotation, mass of second particle and its distance from the second particle, mass of third particle, its distance plus mn into its distance from the axis of rotation. This is the distance from the particle from the axis of rotation, divided by sum of all the masses of the particle. So we can say it means summation of all the mass into distance. So we can write summation of I is equal to 1 up to n mi into xi divided by summation of I is equal to 1 up to n. It means what? First take the amount, first put I is equal to 1, m1 x1 plus, summation means plus, put m is equal to 2, m2 plus x2 plus, put m is equal to 3, I is equal to 3, m3, x3 and so on. So we can write like this, m1 x1 or we can write, so we need not to write this, I is equal to 1, we can write mi xi divided by sigma mi. What is sigma i? Summation of all the masses, which we can call it as total mass of the system. So we can write summation of all the masses is equal to total mass of system of particles, right? This is the definition for center of mass. Now we can write for two particle system about x-axis. Now we can calculate. To calculate COM, center of mass, about x-axis, that is This is x-axis. One particle is situated here at a distance x1 from the origin, and another particle is situated here m2 at a distance x2 from origin. So this is x-axis. This is axis of rotation. In that case, இதோட சென்டர் மாஸ், இந்த ரெண்டு மாஸோட சென்டர் மாஸ் எங்க இருக்கும்? இதுக்கு இடையில தான் இருக்கும். இந்த ஆக்சிஸ்ல இதுக்கு இடையில தான் இருக்கும். So we can write for two particles situated x center of mass, because center of mass is about the x-axis. Here the particle is situated along the x-axis. Xm is equal to m1 x1 plus m2 x2 divided by m1 plus m2. This we can write sigma mi xi divided by sigma mi. Here I is equal to 1, n is equal to 2, because we have got only two particles. So this can be written as sigma mi xi divided by m. This is for the particle situated in the x-axis. Suppose if the particle is situated on the y-axis alone, it means the center of mass will be somewhere here. Why? If m2 is greater than m1, m2 is greater than m1, the center of mass will be near to the heavier body. Since m2 is greater than, this is the heavier body, so center of mass will be situated. This will prove it later by doing some numericals. Properly. Same way we can write what is YCM. Y, center of mass of a discrete particle system about y-axis is equal to sigma mi yi divided by them, and for is about z-axis sigma mi zi by m. If you expand it, m1 z1 plus m2 z2 plus m3 z3 and so on. Suppose if a body is located in the space, the body is located in the space. Space means what? It will have all the three coordinates. All the three coordinates means what? X coordinate, y coordinate, z coordinate. How? This is the x-axis, this is y-axis, and this is the z-axis. So this particle is situated at a distance r from origin. It means it has got x component along the x-axis and y component along parallel to y-axis and z component parallel to z component. It means we can say it has got xi and yj and zk. This is, you must have studied in vector quantity. Or we can write r vector, the position vector of the particle P1, first particle. P1 is located at a distance r, from the origin. R is equal to xi plus yj plus zk. In this case we can write, if there are n number of particles, P2 up to Pn, if n number of particles situated and we want to find the center of mass about r, we can write RCM is equal to m1, which axis we are taking about? R1 plus m2 R2 plus m3 R3 plus mn Rn divided by m1 plus m2 plus m3 plus mn. This can be written as, this how we can write, is equal to sigma mi ri sigma Mi is equal to sigma Mi Ri divided by sigma divided by total mass of the system. This is how we find the center of mass of a system situated at different coordinates. Space means what? In space, in a plane, suppose you take a plane, a particle is located, it means it will have x coordinate and y coordinate. In that case, it will have xcm, comma, ycm. If it is located on any of the axis, say x-axis, it will have only xcm. If it is located on the, it will have, if it is located in the space means 3 dimension. It will have all the three, xcm, comma, ycm, comma, zcm. So this is what the expression for the center of mass. If the particles are not discrete and continuously distributed, it means suppose this is discrete distribution of particle, this is continuous distribution of particle. In this case, what we will do, if the system is not continuous, we will replace summation sign by integration sign. We are integrating all the total mass. xcm is equal to sigma mi xi by sigma mi. Replace sigma by integration sign. So xcm is equal to integration dmx divided by integral summation of all dm. Same way, ycm is equal to integration, which we can write integration x dm by integration x dm. Here also we can write y dm by integral dm. zcm is equal to z dm by integral of dm. rcm is equal to r dm by integral of dm. So there are two types of systems of particle. One is discrete mass system and continuous mass system, in which the mass is continuously distributed either linearly or in a surface or in a volume. Whereas discrete means every particle is separated separately, different masses. So now if we talk about where the center of mass is located, suppose there is a mass m1 here, there is mass m2 here, it is somewhere, and if we say m2 is greater than m1, it means the system center of mass is always located close to the mass having heavier mass, close to the heavier mass. Suppose there are three particles situated like this, m1, m3, m2, and the center of mass will be, if m2 is greater than m1, so it is somewhere located close to the heavier body. This center of mass for this axis is closer here. For this one, if m3 is greater than m1 and m2, m1 plus m2, it will be situated close to m3. This is the center of mass of three particle system located in three different axes. Center of mass, how it plays a rotational motion and how it plays a role in rotational motion and translation motion. Say for body rod eduthuko, see we take a rod like this. Suppose அதோட center of mass இங்கே locate ஆயிருக்குது. Center of mass இங்கே locate ஆயிருக்கு. And we can apply force anywhere on the body. Suppose if you apply along the center of mass, this is line of action. the body will move like this. It means it will have translation motion. Suppose if you apply a force which is along the center of mass, again this body will move like this. Suppose in the body going a center of mass locate ஆகிருக்குது, force பண்ணனும், the body will move exactly upward. இப்படி force அனுப்புறோம்னா it will body move, so it both are linear motion in this direction, linear motion in this direction. It means the force applied is in the line of center of mass, the body will have translational motion. So இங்கே translation motion இந்த பக்கம் மூவ் பண்ணுது, இங்கே translation motion இந்த பக்கம் மூவ் பண்ணுது. Suppose other than center of mass, இப்போ நம்ம இங்கே force இங்கே apply பண்றோம் F. அப்புறம் என்ன பண்ணுவோம்? So this is E of mass, நம்ம இங்கே அனுப்புறோம். So body will tend to rotate above the center of mass. So in this force will tend to rotate the body like this. And this motion we call it as rotational motion. As it is, இங்கே நம்ம ஒரு பாடிக்கு பார்த்திருப்போம். What is center of mass? Center of mass is the point. Center of mass is the point at which every masses of the particle, they say M1, which is at a distance of R1, and M2, which is at a distance of position of this particle M1 with respect to origin. This is called, we call it as position vector in vector algebra. So like this, M3, R3 distance, say about nth particle at a distance of Rn. So its center of mass somewhere at a distance here, which is distance capital R, about its center of mass. So RCM, we calculate RCM. This is the distance of the end center of mass from the origin. This is distance of center of mass origin at which all these masses are supposed to concentrate. That RCM is equal to M1 R1, if we take in vector form, plus M2 R2 plus Mn Rn divided by M1 plus M2 and summation of all the masses. So we can say Mi Ri, if you write in scalar form, Mi Ri is equal to sigma I is equal to 1 up to n particle divided by sigma m into I is equal to 1 to n. So this we can simply write by removing, it means I stands for what? First particle, n goes to second, third, fourth. If you have 3 particles, I is equal to 1, n is equal to 3. This is summation of, that is for 2 particles M1R1 plus M2R2, that indicates a summation sign. 3 particles M1R1 plus M2R2 plus M3R3, n particle M1R1, M2R2, M3 and so on. So we can write Mi Ri divided by M. So this is equal to RCM. This is the distance from the origin at which the center of all, that is all the point masses are supposed to concentrate as a single mass. Okay, if both are having same masses, both the discrete mass system, both are having same masses, M1, M2, where M2 is equal to M1, we can call it as M. So X, it is situated in x-axis and this is axis. X Cm is equal to M1 x1 plus M2 x2. This is x1 and this is x2 divided by M1 plus M2. Or we can write M into x1 plus M into x2 divided by M1 plus M2. Okay. If you take M1 out, x1 plus x2 divided by 2m is equal to x1 plus x2 by m. It means m1 plus x2 by 2. That is In the middle of the center of mass is located if both the discrete mass are having same masses. Center of mass of different object. இது uniform body, non-uniform body. இந்த objectல uniform bodyல center of mass will be located. எங்க locate ஆயிருக்குன்னா அதோட geometric centerல locate ஆயிருக்கும். Square plateல அதோட center, ringல center, cubeல அதோட center, diskல அதோட center, hollow cylinder அதோட center along the axis, hollow cylinder இருக்கு. Non-uniform objectக்கு center of mass geometric centerல locate ஆயிருக்காது, வேற பிளேஸ்ல locate ஆயிருக்கும். எப்படி பார்க்க போறோம்? நம்ம இப்போ சென்டர் ஆஃப் மாஸ் ஆஃப் டிஃப்ரெண்ட் ஆப்ஜெக்டை பார்க்க போகிறோம். அதில் டிஃப்ரெண்ட் ஆப்ஜெக்டில் ரெண்டு கேட்டகரி இருக்குது. ஒரு கேட்டகரி வந்து யூனிஃபார்ம் பாடிஸ், இன்னொன்று நான் யூனிஃபார்ம் பாடி. யூனிஃபார்ம் பாடின்னு பார்க்குற போது ஸ்கொயர் பிளேட், ரிங், கியூப், டிஸ்க், ஹாலோ சிலிண்டர். நான் யூனிஃபார்ம் பார்க்குற போது செமி ரிங், ஹாலோ ஸ்கொயர், ஹாலோ ஹெமிஸ்பியர், ஹாலோ கோன், சாலிட் ஹெமிஸ்பியர், சாலிட் கோன். யூனிஃபார்ம் பாடியில் சென்டர் ஆஃப் மாஸ் அதோட சென்டர் ஆஃப் கிராவிட்டியில் லொக்கேட்டாக இருக்குது, ரெண்டு ஒன்றா இருக்கும். பட் நான் யூனிஃபார்ம் பாடியில் அதோட சென்டர் ஆஃப் மாஸும் சென்டர் ஆஃப் கிராவிட்டியும் வேறு இடத்துல இருக்கும். சென்டர் ஆஃப் கிராவிட்டி அண்ட் சென்டர் ஆஃப் மாஸ் ஆர் நாட் சேம். இட் இஸ் ட்ரூ. ஃபார் சம் பாடி சென்டர் ஆஃப் மாஸும் சென்டர் ஆஃப் கிராவிட்டியும் ஒரே இடத்துல லொக்கேட் ஆகிருக்கும். பட் சில பாடிஸில் நான் யூனிஃபார்ம் பாடியில் அது இருக்க சான்ஸ் கிடையாது. ஸோ இதோட பார்ப்போம். நான் யூனிஃபார்மில் ஏன் இதை பற்றி பார்க்கணும், இது வந்து என்சிஎட்டில் கவர் பண்ணல. என்சிஎட் கவர் பண்ணாலும் ஜேஇ மெயின்ஸ் அல்லது நீட்டில் வந்து இதில் சமயத்தில் ஒரு 1-2 கொஸ்டின்ஸ் கேட்குறாங்க. ஒரு கொஸ்டின்ஸ் வந்துடுது சமயத்தில். ஆல்மோஸ்ட் ஆல் த டைம்ஸ் வருது. அப்படிங்கிற போது நம்ம ஃபிங்கர் டிப்ஸில் இருக்கணும். ஃபிங்கர் டிப்ஸில் இருந்தால் ஈஸியாக இந்த ப்ராப்ளத்தை ஜஸ்ட் 20 செகண்ட்ஸ்க்குள்ளே நம்ம சால்வ் பண்ணிடலாம். ஃபார் செமி ரிங் இட் இஸ் லொக்கேட்டட் at 2r pi where r is the radius. r அதோட ரேடியஸ்ன்னு வச்சுக்கிட்டோம்னா 2r pi இந்த இடத்துல லொக்கேட் ஆகிருக்குது. ஃபார் செமி டிஸ்க் 4r by 3 pi and hollow hemisphere r by 2, hollow solid hemisphere 3r by 8, hollow cone ஹைட்டு, இங்கே வந்து ரேடியஸ் பார்க்குறோம், இங்கே ஹைட்டு h by 3 and solid cone it is h by 4. ஸோ இவ்வளோ ஃபார்முலா நம்ம ஞாபகம் வச்சுக்கிறது கொஞ்சம் கஷ்டமாக இருக்கும். ஃபார்முலா ஞாபகம் வச்சுக்கிறது. ஸோ வில் யூஸ் த ஷார்ட்கட் மெத்தட். எப்படி? ஃபஸ்ட்டு வில் யூஸ் சம் அப்ரிவேஷன் லாங்குவேஜ். சினிமா போகிறோம், அதில் நடிகர் யார் இருக்காங்க? சினிமா தியேட்டர், ரித்திக் ரோஷன் அண்ட் ஸ்ரீதேவி. சினிமா தியேட்டர், ரித்திக் ரோஷன், ஸ்ரீ தேவி. ஃபஸ்ட்டு 6 1 2 3 4 5 6. ஸோ ஃபஸ்ட்டு 3 விட்டுட்டு செகண்ட் தேர்டில் வந்து 2 3 4. அதே ஃபஸ்ட்லேருந்து ஆரம்பிக்கும் அந்த ஆர்டர் ரிவர்ஸில் எழுதணும். 4 ரிவர்ஸ் டினாமினேட்டரில் 3 2 4 3 2. இங்கே வந்து பையிலேருந்து ஆரம்பித்து 8 3 5. Now we are almost done, முடிச்சிட்டோம். ஸோ 4 by 3 pi 4 by 3 pi 4 by 3 piங்கிற போது இது வந்து செமி டிஸ்க். திஸ் இஸ் ஃபார் செமி டிஸ்க்னா டிஸ்க்குன்னு பார்த்த மாதிரி R வரும், ரேடியஸ் 4r by 3 pi for semi disk. அடுத்தது 3 by 8 வந்து solid cone. கோன்னாலே radius is characterized by radius. Then 2 by pi. 2 by pi. 2 by pi is for a ring. R stands for ring. To ring in a radius. At the H. H stands for hollow. Hollow of what? Hollow hemisphere. Solid hemisphere. Hollow hemisphere. Hollow hemisphere radius தான் வரும். Radius தான் வரும். So hollow hemisphere R by 2. R by 2 hollow hemisphere. Then T. T stands for hollow cone as well as triangular lamina. Triangular lamina base length height எடுக்கிறோம். So triangular lamina h by 3 height. Height is the parameter h by 3. Next is 3 by h by 4. Hollow cone, this is for solid cone. Solid cone na அதுவும் h தான் h by 4. With this help we can take all the formulas for different bodies having its center of mass at what place. அதை நம்ம தெரிஞ்சுக்க முடியும்.